In BYU football history, there is a very iconic play. No, not that one. This one. This play had some people calling it the darkest day in BYU football history. The coaches received so much ridicule for this choice, and people still talk about it today. BYU TV even made a 5-minute mockumentary about how stupid the play was. Is this the stupidest call in BYU football history? Well, it turns out the math is actually on the coach's side here. Yes, the math shows that it is not unreasonable to attempt a fake punt on 4th and 19 from your own 5-yard line. How do you mathematically judge the quality of a decision like attempting a fake punt? There are a few different ways. One way is to look at the way the probability of winning changes with each decision. Unfortunately, I don't have the models that websites like ESPN use to generate the probability to such accuracy, so we can't do it that way. Another way, though, is to compare the average number of points you would expect to gain or give up with each choice, and make the decisions that helps the most or hurts you the least. Since I mentioned average, many of you will be thinking that we will calculate averages from data, but it's hard to get data for such specific situations. We would need to know field position before the fake punt, the scores of each team before attempting the fake punt, and the scores of each team after the subsequent drive. Finding averages this way is possible, but finding the data will be challenging and lengthy. Even if we limited it to just the team in question, since they have particular strengths and weaknesses, our sample size might not be large enough, since this type of play is not very common. So how do you calculate averages when you don't have data? Well, let's look at a simple situation. What if we wanted to know how many moves, on average, you expect to move in a board game by rolling a fair 6-sided die? We could roll the die a lot of times, see a couple thousand, write down the result each time, then add them all up and divide by the total number of rolls. But what would we expect if we did that? It's a fair die, then each number would have the same chance of coming up, so we would expect about 1/6 of the values to be 1, and 1/6 to be 2, 1/6 to be 3, etc. But if we had 1,000 rolls that had roughly an equal distribution across the values 1 through 6, then we would expect the sum of all those numbers to be about 1/6 of 1,000 1s, plus 1/6 of 1,000 2s, plus 1/6 of 1,000 3s, etc., all the way up through 6. Then we could calculate the average by dividing by 1,000, the total number of rolls. That expression simplifies to just 1/6 times each of the values, which is the probability of each die roll multiplied by the resulting number rolled, all added together. This formula generalizes to find average values in other situations, even if the probabilities are not the same for each option, like our football example. When using this calculation method, the average is usually called the expected value. It's a weighted average of the different outcomes with the probabilities as the weights. Consider a simple lottery where there's $1 million prize, 1 million tickets, and tickets cost $2 each. Is playing this lottery a winning proposition? The expected value says no. You would expect to lose about $1 for every ticket you played. We will use expected value to calculate the number of points BYU expects to score, and Boise State, the opponent, expects to score given these two scenarios: to punt or to fake the punt. Let's start with the fake punt. BYU made about 67% of their 4th down conversions during the 2016 season, but most of those would be short down situations, so 4th and 19, even if you do catch the other team off guard, is going to be much lower than that. Let's give BYU a 20% chance of being successful, and say they end up at their 25-yard line or so, barely making it. That means there's an 80% chance for Boise State to make the stop. We will assume that BYU gets out of the end zone, so no safety, but doesn't get out of the 20. So Boise State gets the ball in the red zone. We can use some red zone statistics to get reasonable probabilities for Boise State. They had 52 red zone appearances that year, scored a touchdown on 35 of them, a field goal on 9, and had no points on 8. That gives us probabilities of about 67%, 17%, and 16%. If BYU is successful on the fake, we've assumed they end up at the 25-yard line. What's their probability of scoring? For the season, BYU scored a touchdown on about 27% of their possessions, a field goal on about 12, but their average field position was much worse than the 25. For that season, it was around the 12-yard line. So let's round up a little, with 30% for a touchdown, 15% for a field goal. So if BYU is successful, they expect to gain 0.3 times 7 plus 0.15 times 3 plus 0.55 times 0, which is 2.55 points on average. This is reasonable since their expected points per possession when starting on the 12-yard line rather than the 25 was 2.36 for the season. If BYU fails, then Boise State gets the ball in the red zone, and they would expect to end up with 0.67 times 7 plus 0.17 times 3 plus 0.16 times 0, which is 5.2 points on average. So BYU would expect to be down 5.2 points if they failed the fake punt. So on average, if they fake the punt, they have a 0.2 probability of 2.55 points and a 0.8 probability of being down 5.2 points. So an expected value of a negative 3.65 points. Not good for BYU. If they attempt the fake, they expect to be down about half a touchdown. It doesn't look like a good choice, so let's look at the alternative. What if BYU punts? Let's assume that BYU gets the punt off. It goes 40 yards to the 45-yard line, a decent punt, especially from the back of the end zone, and Boise gets a return of 5 yards, which was about their average return that year. So Boise State ends up with a ball at BYU's 40. What are the probabilities of Boise State scoring from there? The probabilities would be worse than the red zone probabilities, but better than their season averages, where they started, on average, at their own 25-yard line. So let's pick 50% for a touchdown, 20% for a field goal, and 30% for nothing. That gives Boise State an expected value of 0.5 times 7 plus 0.2 times 3 plus 0.3 times 0, which equals 4.1. So if BYU punts, they would expect to be down 4.1 points. Ouch, that is worse. That's worse than the 3.65 points than if they fake it. So what is going on? BYU is just in a bad situation. They expect to be down about 4 points no matter what they do by the end of the next drive. This is just due to the horrible field position. Giving Boise State the ball in the red zone isn't much different than giving them the ball on BYU's 40-yard line. So that means it doesn't cost BYU much more if the fake punt fails. After the game, one of the BYU coaches said that they had studied film of Boise State and thought that BYU would have a good chance of being successful on the fake if Boise State showed a certain formation on the punt coverage. They called the fake punt because Boise State showed that susceptible coverage. That means our estimate of 20% success rate might actually be low. In the moment, the coaches would have made it higher, maybe a third or even a half. That would have really tilted the average in BYU's favor. So if it's reasonable for a team to go for it on 4th and 19 from their own 5, then when should you punt? Well, if you trust the math, almost never. That's exactly the philosophy of this high school coach who rarely punts because he did the math. You can see a video about that coach and his tactics and a link in the description. But even if you don't want to trust the math to never punt, I've heard one sports statistician recommend never punting if you're outside your own 40-yard line. So why do coaches punt so much if the math says not to? Part of it is understanding the particular situation. For example, considering how much time is on the clock. That's something that we didn't consider. And also considering how effective your defense has been lately. After all, you aren't playing the average of the opponent across all games and drives. But coaches have additional information about how they're doing in that particular game. But a piece of it might be more of a political decision than a strategic one. Fans don't know the math, so coaches get criticized when they go for it and it doesn't work out. Just like what happened with BYU. By the way, if you're wondering what happened, Boise State got the ball on about BYU's 2-yard line, but came away with no points. So is this the worst play call in BYU history? Definitely not. It seems that the play was poorly executed, but the call itself was reasonable. What is the worst play you have ever seen in football? Tell us about it in the comments. I once saw a team punt on 3rd down. That is at the top of my bad play list. Thank you for watching. Please subscribe and share our videos. Be sure to follow Math the World on Twitter, Instagram, and Facebook. Thank you so much for your support.